Welcome back, focused learners. Today, we're stepping into the completely mind-bending world of quantum computing. If you've been hearing all the buzzwords lately but felt a little lost in the complex physics of it all, well, you are in exactly the right place. In this explainer, we're going to break down the mechanics of quantum computers. These are advanced machines that use the incredibly weird rules of quantum mechanics to run calculations at speeds that are just absolutely unattainable by even the most powerful supercomputers we have today.
Here's our roadmap for today. We'll kick things off with Section 1, the quantum leap. Then move to 2, classical versus quantum. 3, superposition and entanglement. 4, inside a quantum computer. 5, achieving quantum supremacy. And finally 6, the quantum future.
All right, let's jump right into Section 1, the quantum leap.
So to really grasp how fundamentally different a quantum computer is from that device sitting on your desk right now, I want you to imagine you're playing a super complex game of chess. Naturally, to win, you'd want to perfectly predict your opponent's every possible move, right? Well, if you use a regular classical computer to help you map out this chess match, it'll analyze your opponent's potential strategies, sure, but it has to go through every single move one at a time. It checks a move, evaluates it, finishes, and then moves on to the next. As you can imagine, running through every single possibility sequentially like that is just incredibly time-consuming. But a quantum computer, it would simulate all the possible moves of your opponent at once, in just a fraction of the time. It literally doesn't wait in line.
Okay, moving on to Section 2, classical versus quantum.
While the devices we use today and the machines of the future both rely on circuits, chips, and logic gates run by algorithms, their core processing methods are just entirely different. Classical computers rely on rigid binary bits. They're always either a 0 or a 1, representing the absolute on or off state of an electrical current. Quantum computers, on the other hand, use these fluid, dynamic things called qubits. And the crazy thing about qubits? They don't have to choose. They can actually exist in both the 0 and 1 states simultaneously.
That brings us to Section 3, superposition and entanglement.
To understand how qubits manage to pull off this incredible feat, we really need to look at two massive foundational concepts in quantum mechanics. Let's start with superposition, and we'll use an everyday example to picture it. Think about flipping a coin. When it finally lands, it clearly shows either heads or tails. But think about that exact moment when the coin is actively spinning in the air. What state is it in right then? Is it heads or is it tails? While it's spinning in a blur, you could accurately argue that it's both heads and tails at the exact same time.
And that brilliantly illustrates superposition. Just like that spinning coin, a qubit can exist in both the 0 and 1 states simultaneously. This property opens up a completely and fundamentally different way to process information. Because of superposition, a system of multiple qubits can hold multiple states all at once. This allows the quantum computer to process tons of solutions simultaneously, which is something a classical computer simply cannot do.
But, the magic of quantum mechanics doesn't actually stop there. These multiple states of multiple qubits can be linked to each other through a wild phenomenon called quantum entanglement. When qubits become entangled, the operations of one qubit instantly influence the other qubits, no matter how far apart they are. They influence the entire system. This deep, invisible link unlocks significantly higher computational power, allowing the whole system to work completely seamlessly together.
Now for Section 4, inside a quantum computer.
With all of this incredible invisible magic happening at the subatomic level, you might be wondering what a quantum computer actually looks like sitting in a room. Well, I can guarantee you, it looks absolutely nothing like your sleek laptop. If you walk into a facility housing one of these, you're greeted by this huge, incredibly complex-looking machinery. It hangs down much like a giant, intricate chandelier, gleaming with golden, silver, and blue parts. And it's surrounded by a literal maze of wires, cooling tubes, and other intricate components that are needed to maintain those highly sensitive quantum states. Honestly, it's a setup that looks straight out of a blockbuster sci-fi movie.
Let's look at Section 5, Achieving Quantum Supremacy.
So, while quantum computers have existed in various experimental forms for a few years now, there was a very specific moment when the theory powerfully proved itself in reality. That moment arrived in October 2019. That was the year Google asserted they had achieved a massive, highly sought-after breakthrough known in the field as quantum supremacy.
The crucial point here is what quantum supremacy actually means.
Essentially, it meant that Google used their specialized Sycamore processor to perform a specific type of computation much faster and way more efficiently than the most powerful classical supercomputer on Earth. They proved, for a fact, that quantum computers can indeed surpass classical machines by leaps and bounds on specific tasks. This validation was an absolute shockwave. It prompted massive research investments and intensified development from tech giants like Microsoft, IBM, and dozens of ambitious startups.
Finally, Section 6. The quantum future.
As we look ahead, we really have to ask what happens when this technology matures. Realizing the full potential of these processors is going to herald a world of truly unimaginable possibilities. Because they can process extensive amounts of data at completely unprecedented speeds, the real-world applications are just staggering. For starters, quantum computing will massively enhance artificial intelligence and machine learning. In the realm of cybersecurity, it could uphold virtually unbreakable data encryption during active use. It's poised to entirely revolutionize medical and drug research by accurately simulating complex molecular structures. We're also looking at next-generation weather forecasting and massive leaps forward in automobile battery technology. The impact is going to be felt across almost every major industry.
Now let's bring this back down to earth for a quick second. It is true that large-scale commercial use or having a quantum computer in your own home is likely many years away. But as this tech scales, it's not an exaggeration to say it might one day help solve incredibly complex, everyday problems too. I mean, maybe one day this immense processing power will help you predict the perfect outcome for a dinner date, finally locate your missing socks, or even calculate exactly why you walked into the kitchen only to completely forget why you were there in the first place.
So we've explored the leap from rigid binary bits to fluid qubits, the totally mind-bending reality of superposition and entanglement, and those wild chandelier-like machines preparing to change our world. As these quantum leaps continue in labs all around the globe, I want to leave you with this final provocative thought. When the full power of the invisible quantum realm is finally unleashed, how will it directly disrupt your daily life? Keep exploring, keep learning, and I'll catch you in the next explainer.